Hi, welcome to Expertisor Academy. This is Giri, lecturer in physics. In this video, we discuss about the methods for producing the induced EMF. So we have three methods to produce induced EMF. Okay. So before entering these methods to produce induced EMF, so what's the meaning of induced EMF? So how to generate it? Consider two types of the or individual coils. First, you generate the current in the first coil, that is primary coil. This primary coil produces the magnetic field around it. This magnetic field influences the another coil, that is secondary coil, by passing the magnetic field lines through the secondary coil. In this secondary coil, the EMF is generates. This EMF direction is opposite to the EMF in the first coil. Okay, here the induced EMF is changing with respect to the time. Changing with respect to the time. So in this induced EMF, definitely we have a induced current. You have to produce the induced EMF. There is a induced current in that coil. Okay. So simply, what is the meaning of induced EMF? Already there is a existing EMF neighboring coil. The EMF is generates in secondary coil. This direction is opposite to the primary coil. That is the induced EMF. Okay, let's go for the electromagnetic induction. So, what is the meaning of electromagnetic induction? That is the production of induced EMF. It's nothing but a electromagnetic induction. Production of electro or induced electromotive force. That's the electromagnetic induction, and also the production of the induced current. Okay, now we discuss the definition of Faraday's law of electromagnetic induction. Okay, so the definition of the Faraday's law of electromagnetic induction is the induced EMF, that is equal to rate of change of flux in the coil. Okay, see this. According to Faraday's law of electromagnetic induction, an EMF is induced in a circuit when magnetic flux linked with changes. This EMF is called induced EMF. See here, induced EMF, that symbol is epsilon, that is equal to rate of change of flux. This flux must be equal to BA cos theta. This B is the magnetic field, A is the area of that conductor. This cos theta represents angle at that particular place of field lines and the flow of current. Okay. So this is the Faraday's law of electromagnetic induction. So simply, what's the meaning of Faraday's law of electromagnetic induction? The induced EMF must be equal to rate of change of the flux in that coil. Okay. Let's go for the methods. The first method is induction of EMF by changing the magnetic field. Okay, see this information about this first one. From Faraday's experiments on the electromagnetic induction, it was discovered that an EMF is induced in a circuit on changing the magnetic flux of the field through it. So, how to generate the EMF in first method? That is, have to change the magnetic field in the or magnetic flux in that wire, it gives the induced EMF. Okay, see here, the change in flux is brought about by relative motion between the circuit, relative motion between the circuit and the magnet. First experiment, we have the Faraday's 2 experiment, that is the relative motion of the magnet, and also variation or increasing the value of current in the coil or decreasing the current in the coil. Okay, so in first method, relative motion between the circuit and magnet, here definitely we observe the change in magnetic field. In this situation, the induced EMF is develops. Okay, this is the method of first. Coming to the second method, here, induction of EMF by changing the area of the coil, changing the area of the coil. So in this method, you have to observe the magnetic field, that is B. Here, there is a conductor that length is capital L. At the initial point, AB is the place of the conductor L. It is moving from AB to CD place. Here in this conductor, I is the current which is passing through it. Here the distance traveled by the L length of the conductor is V into dt. So here V is the speed of the conductor which is moving. Here magnetic field is perpendicular to the field, or this symbol indicates the perpendicular inverse, perpendicular inverse. Okay, so this is perpendicular to the surface area of the conductor. Okay, let's go for the derivation part of this induction of EMF by changing the area of the coil. Okay, let's see here, change in flux must be equal to magnetic field into change in area, magnetic field into change in area. So here area, it's nothing but a area of ABCD. Look at this picture, this is the first initial point, this is the final point. Consider this is ABCD of this area, that is equal to ABCD, that is equal to L into V into D, length into breadth. So substitute this value here. So this one represents d phi divided by dt, that is equal to BLV. So finally we got the relation induced EMF epsilon is equal to rate of change of flux, that is equal to BLV. Okay, so this EMF is called motional EMF. The direction of induced current is found to be clockwise from Fleming's right hand rule. By using the Fleming's right hand rule, this direction, this induced current direction is clockwise. So what is the Fleming's right hand rule? You have to arrange your thumb, fore and middle fingers in three-dimensional way. Here, these three fingers indicating the three different properties. Here, thumb represents the force applied on the magnetic force, and forefinger indicates the field, middle finger indicates the induced current directions. Okay, so this is the second method to find the induced EMF. So this is the methods to find the induced EMF. In this video we discussed only two methods. We have another method to find the induced EMF. That method is discussing in another video, that is next video. Okay, thanks for watching this video. For more videos visit www.expertisoracademy.com. Thank you.